Well, thanks for the invitation. This is actually my first talk at the AMLD, so it's very exciting for me to speak. And I specifically also want to thank the organizers because last year this track was extremely highly rated, and so we were super eager to see that you came back. So I want to talk a bit about what we do in the lab, and thanks for the introduction also that was just made. I mean, I should maybe, before I begin, say that I have no deep expertise in nutrition. Actually, the reason why in my lab we now work on nutrition is a bit based on what was just mentioned. So I run a lab that's called Digital Epidemiology Lab. We apply machine learning to questions of public health, but has traditionally been closer to what we would perhaps talk in the AI and health track. So tracking public health information, and specifically also a bit with a focus on infectious diseases in the world around that. But when a few years ago, I had the opportunity to start working on food, and I thought it could be quite interesting, even though, again, it's not my expertise, but that we could probably bring some of the digital tools that we're good at in my lab to a world that I think needs it. And that's not to say that nobody else, of course, there are many people working on it, but I think the more we work on this from a technical perspective, the better also. The problem, so what's so interesting, of course, about food is that you can, this is famous from farm to table saying, but actually my preferred saying is from farm to toilet, because that's the real pathway, right? It starts with the farmer and eventually ends up on the table. But then is actually, from what interests me, is where the interesting things begin, where it goes through our system, where it interacts in many complex ways with the human body, and expresses itself in all of its varieties of health and illness, and then eventually, of course, gets discharged. And so our work is more on that side, but of course I fully recognize that the part before is just as important in a sustainability context. But what we work on is more from the healthy food. Now, healthy food is such an empty term. Healthy food, yeah, of course, nobody wants unhealthy food, as we learned. Healthy food mostly means, from a public health perspective, that we don't get sick from it. And then ideally, we also prevent diseases in the long run. And that's an interesting phenomenon nowadays because, of course, traditionally, the challenge of the world was to make sure there was enough food. The challenge of the world now is to make sure that there's the right food and not too much for everyone, because when you look into the stats and you say, what is the biggest contributor to healthcare costs, it's very hard to not see the effect of food. It's very, very strong. Because at the end of the day, from a public health perspective, there are 4 things that affect human health outside of infectious diseases. That's by and large exercise, alcohol, cigarettes, and food. And that's why whenever we go to a sort of public health conference, this is always, of course, the message also from public health: don't smoke, don't drink too much, exercise more, eat healthy. Now, the first 3 are fairly straightforward, right? There's no debate anymore. Yeah, no smoking is good, end of story. Drinking less alcohol is good, end of story. There's maybe some debate about, is a glass good or not? But by and large, drink less, exercise more. You can also overdo it, but it's fairly clear. However, with food, it's not clear. Eat less food is not per se a good statement. Eat more food is also not. And then what to eat? So it's actually, nutrition is complicated and it affects us in many complicated ways. And this whole field has done amazing work It's getting a lot of bad press these days. Just this morning, I read a paper in the Annals of Internal Medicine, again criticizing this field for the fact that we know very little, that it's 2020, and we know very little about what constitutes healthy food. Now, there's multiple reasons for this. Certainly, there have been methodological issues, but that would be true for every field. So I don't think that's extremely meaningful criticism. The second, for which I think there's much more evidence, that's much more interesting also, is this high interpersonal variability. What is healthy food for you is not necessarily healthy food for me. And that just can't be said for cigarettes, for example. So the strategy that we deployed in the past few years is essentially the following, because we had this chance to take a holistic view and start things from scratch and have sort of a 10-year view, which is one of the privileges, of course, of being in an institution like EPFL. First, we thought what is really needed is actually some good data. What is actually food that's on the market? And I'm not just saying apples and oranges. I mean every single product that you can buy in a food store. Because it's actually a fairly data-driven thing. You walk into a food store, you have thousands of products with unique barcodes, with lots of data, and much of it standardized. But it didn't exist in an easy-to-access version. So we built this database, and I can say a few words about that. And then when we said, okay, once we'll have that, we should be able to build an app that helps people easily track what they eat using this database, but then also just by taking pictures and leveraging the recent breakthroughs in machine learning and image recognition. So that would be then the mobile app. It's called My Food Repo. So that's sort of your own food repository, right? Your own personalized food repository. And then we can use this for cohorts. So now if there's a medical cohort that says, what is the effect of food on X? And X can be onset of diabetes, response to certain cancer drugs, what have you, right? Medical cohorts, they want to know what their participants eat. And so they could then use this app. And we were also lucky that we got good support from a foundation, the Jepson Foundation, to actually also run our own cohort. So I will talk about this briefly as well. But in the long run, I mostly will focus on this part, because in the long run, I think that's where the strength is of the lab. Running cohorts is definitely something that is also now a strength, but running cohorts is it doesn't easily scale, obviously. If you want to run 5 cohorts, you need to bring in massive funds. However, if you have a mobile app and with a good technical backend, that could all of a sudden be used by 100 cohorts. So let me then begin briefly describing this Food and You study. So this is a citizen science project at foodandyou.ch. It's currently focused on Switzerland. The idea is to track people on what they eat with the app, to give them a blood glucose sensor so that we can measure the blood glucose. And we measure a few other things as well, exercise and so on. And all of this is done through digital means, so either through the app or through the web. And that's why we call it a digital cohort. We actually never need to see anyone person to person. We also ask people to send us a stool sample so we can then analyze the microbiome. This is what the website looks like. So it's about citizen science, nutrition, blood sugar, and so on. And as I just mentioned, we ask them to use the app for 2 weeks, and we send them this Abbott sensor so they can measure their blood glucose response and a stool sample. And what we're currently doing is it's a citizen science project, so we also want to give people information back. We're currently implementing this. This should be done very soon, but so that you can then really see, okay, here, was my glucose response. I mean, you already see it in the app, but on the website then matched with what you ate. And so you can understand, okay, when I eat this, my blood glucose goes up by a lot. And then also just patterns, right? Daily patterns of when do you actually eat? Are there interesting patterns? Because we're also starting to learn as a field that it's not only important what you eat, but when you eat it. And in particular, also when you don't eat and for which time periods. I mean, I'm sure you have heard about all this exciting research on intermittent fasting and 2-day fasting, 3-day eating, or 16 hours not eating, 8 hours eating. So, but there's very little data because the way usually we track what people eat is with food frequency questionnaires that do not capture this at this granular level. And then, of course, all kinds of other things that you could sort of macronutrients and so on. We're building this now. It's almost done and should be in the app very soon. On a bigger level, I find this very exciting because I think it's one of the ways that medical cohorts will develop over time. And where traditionally it used to be that you would go to a physician or to a hospital and you sort of have that bottleneck of the experts and the hospital or the health practitioners, and they would take all of these measurements. But we're now obviously moving into this world where I can easily track my blood glucose level and share this information completely digitally with my physician or anyone for that matter. I don't even need anyone's agreement. I can just buy one of these things and put it on my arm. And microbiome, increasingly the same thing. So, the companies like 23andMe and so on, I mean, some of these are obviously not getting a lot of good press these days, but as a general principle, the fact that we can increasingly measure this stuff about ourselves means that I think we'll see really a fundamental shift of how medical cohorts are organized. There's even now batches that you put them on, and then a few minutes later you take them off, and you have sealed blood that you can then just send in an envelope to some lab. So you don't even need to go for a blood test anymore to a particular health location. And that I think will change a lot of things. So that's exciting too. So that's sort of the vision of the digital cohorts. I should probably change this picture because this is a product of a company that has just been raided by the FBI. So maybe I should remove that. It was a microbiome sort of company. Good. Speaking now briefly, and just mindful that I don't see a watch here. What's the, sir? There's no. Is what? 30. Okay, I'm good in time. This database, right? So here on the left now, moving all the way to the left, let me just say a few words about the database because that's going to be important. That's an independent and a community-driven open database for barcoded food products. So what do I mean by this? So this is what, if you go to foodrepo.org, this is what it looks like. It has many products. It currently has, actually this is slightly outdated, but that order of magnitude, a bit more than 40,000 products of barcoded food products. So if you go into a store, right, and there's a Snickers or whatever, right, a bottle of water, and pretty much anything you buy comes with a barcode, as you know, and that barcode is the unique identifier of this product. And even though the information about this product is on the package, that is not particularly helpful. It's helpful at the moment of purchase, but then not later. You wouldn't know what exactly was in the product when you ate it, when you want to think about this a week later. So, and it's easy. It's very hard to compare products if you don't have a database. So we said, okay, let's build this database and let's make it ultimately community driven because we can maybe kickstart this, but in the long run, we cannot maintain this. So this is, so now when people use our app, and I'll show that in a minute, and they scan a product and the information will be shown and it will be stored that you ate this product with that macronutrient composition. But also, if the product is not in the database, the app actually asks you to take a picture. So then we can digitize it, and so that's how it can keep growing. And this is very important to us. This is another screenshot from the website, and it's on the main page, so it's not in some 4 clicks down the road. We're really serious about this data being openly accessible for other developers, so that if you for some reason need this information in your app, and we don't even want to know what it's for, you can just get an API key and start basically consuming this data for your app, and increasingly many apps are doing this. Okay, so let me now come to the core, which is this My Food repo. So that's this food tracking app. That again, the cohort uses it, and many other cohorts use it now as well. And the app consumes a part of the database data. So this is a smartphone app. It tracks food consumption. It uses AI to analyze the photos of meals when people take pictures, as well as barcoded information from this other database. And so really that's sort of the vision, right? We say, okay, if we want people to use an app to track food, it has to be maximally easy. And some of the apps we looked at are not maximally easy. And so essentially we just wanted to take all the work away from the user. Because someone at the end of the day will have to do work, right? And if you give someone a food frequency questionnaire, you put it on the patient or the user and say, you're going to do all the work. Now there's apps out there where you can take a picture and then the app makes you insert the data into the app. So essentially it looks like a cool and easy to use thing, but you're doing just as much work as you did before. Now we just do it on a crappy mobile interface. So we said, no, let's actually, in our vision, right, we would like to remove this work completely to the machine. That's a long-term idea. So basically tracking food just means taking a picture, done. In reality, this is not yet where we are, and I show you where we are. There's still a step that requires a human annotation, but we're not putting that back on the user. We actually have people on the team who are doing this. But this is a short-term, eventually a short-term solution, but we can then get more data to improve the algorithms. I'll show you that in a minute. So it's a very simple app. This is what it looks like. And again, all of this information, so I just took the picture. This is my actual food. I just took the pictures, and then when you take a picture, it just says dish with a little hourglass, meaning it's being treated. What happens is that very moment when I take the picture, it is analyzed by neural networks for segmentation, classification, and eventually also weight estimates, although at the moment we do this mostly based on portion sizes. And then it gets shown to a human annotator on a web-based interface, and it says, here's what the algorithm says about this picture. Is this correct or not? And the human annotator then either says that's fine, or he or she says, no, that's not correct. This is the correct segmentation or classification. But eventually somebody has to push a button, and then this shows up in my app. And I can still disagree, by the way. I can still say, actually, this was not, it looks like, but it was actually. So that's also possible. Here's another screen. This looks like a very boring screen, but it's potentially the most important screen of this app, because what this shows you is that this app allows you to subscribe to cohorts. And what that means is that if you run a cohort, let's say you're a hospital or a company or some organization that has a cohort of people, you say, I would like these people to use this app to track their food for some time. You can come to us and we can give you we create a cohort and we give you a bunch of unique keys, sort of almost like passwords. And you can then assign those to your participants or to your patients. And when they then download the app and they say subscribe and they enter that code. Now we know they are part of your cohort, and all the data just needs to go directly to you once it's analyzed. So that makes it very easy for cohorts, eventually around the world, we hope, to just use this app and tell their users or their patients, just enter this code. And we don't need to know who these people are. Frankly, we don't want to know who they are, because then that makes everything very easy from the IRB. But we're happy to see their images, because that will help us improve the algorithm. So how can we improve the algorithm? We can improve the algorithm by saying, well, let's just collect more data and then we can do better AI. And that's probably also 80% of what we hear at this conference. And it's, of course, not a bad idea. You need to get more data and then you can train better algorithms that makes your product better, that eventually gives you more data and so on. We felt, and perhaps many people in this room can relate to this, that we were probably not the ones who were going to build the world's best algorithms for food recognition. Even though I think we're a very good lab, but still at the end of the day, the world's a big place and there's always smarter people than you. And so we thought, wouldn't it be nice if we could take these pictures and actually turn that whole idea of who can build the best food recognition algorithm into an open challenge. So in order to do that, we need two things. We need, first of all, we need an agreement from the users that we can actually use their data. So this is little toggle here. That's why I'm showing this slide. You can turn it on if you want to. Obviously GDPR. Despite at Snowden, it exists and we use it. And we have to turn it off by default, so people have to turn it on. And yeah, I don't know the latest data, but somewhere in the order between 30–40% of people, maybe even 50, turn this on. So people are happy to share their images openly for research. So that's one thing you need. And this is incredibly important because if you want to train an algorithm, obviously you need food data. The usual way to go about and get food data is to go to large databases of images, and Bing and Google and so on are the usual suspects. But you can just not force these search engines, and by no malintent of their own, but by the design of the internet, you can just not force them to give you actual food images. They'll give you this, and this is not food, right? Nobody eats this. I mean, somebody will eat, but that's just not... Tell me when a table has ever looked like this, right? When you actually ate. Never. This is, food porn, or it is, Instagram, but it's not food. And even if you force Google and say, no, I meant regular food, right? Real food. Even then, okay, it looks a bit better, but I don't know if your breakfast table looks like that. I mean, hopefully in your hotel or something like that, but it's just not really real, right? This is the reality of food. These are the images that we get from the users who use this. And these are really ugly images. And nobody would ever put that on the internet. Why would you put that on Twitter, right? You would lose all your followers. Some of these may be, from me. I don't know. But they were publicly shared. And I'm actually certain all of this food was absolutely delicious in the moment when you ate it. You were perhaps with friends, or you cooked it for yourself, or whatever. You had the smell, everything. But food, it just looks ugly on the picture. And so that's why whatever food picture you find on the internet is essentially a lie. So we thought, okay, but now we have these tens and tens and tens of thousands of images from actually real food. So let's put that on the web. And then let's generate a challenge. And just by the way, this is what our annotation looks like. So this is a good example, right? The segmentation, so what is food actually on this picture, what is actually edible, was correct, but the classification was not. The algorithm thought this was red cabbage, which is not. It's some pasta with some tomato sauce. So this has to be corrected, and then other things can be added as well. And then you say go, but so that's what the food annotators look at on a daily basis, or things like this. Tomato, carrot, egg, and then you can also add things that are actually not visible, right? How you want to really say, by the way, I put some lemon juice on it. You will never recognize this, so you will need a little bit of human annotation. Voila. So the second thing then is, fine, now you have the data, you have the user's consent. Now you need to make sure that bright minds around the world are saying, okay, let me take a look at this and let me see if I can beat the best algorithms. So it so happens that we also a few years ago, somewhat in parallel, and really when these projects had no interaction whatsoever, we built another platform that was called Crowd AI at the time, that some of you may remember, where we put machine learning challenges online. We then last year spun it off because it became too big. And so now we're working with this platform, AI Crowd, it's now called, to actually run this challenge. And so this is essentially what it looks like. It's actually live on AI Crowd if you want to take a look. But so now we're putting this problem essentially there, and we say, okay, here are X thousand images with human annotations. Your goal is to now develop an algorithm that is better than what we can do, or better what the current state of the affair is. And this is an ongoing thing. We got funding by the C-Ray Foundation to do this. So it's something that we started a couple of months ago. First round just finished. Second round just launched today, in fact. So that's going to go again for about 2 to 3 months. Then there's going to be a third round, a fourth round. This is sort of an ongoing benchmark now. And every round we can add more images because we have more images from participants. And it's all in the open, and we'd really like this to be a new sort of standard, because again, when people submit their code, they get prizes. I think the people who won this challenge were also invited to AMLD. I think they're right now speaking at the track in another room to students, I think even from India, who just published the best algorithm. It's not yet at a great accuracy, but it is already at a good level. And now in the next round, the goal is to push this, right, a few percentage points up. And then next round, again, a few percentage points up. Every small improvement that looks like really numerically a small improvement is going to save the human annotators weeks. So we just want to squeeze this until it can't be squeezed anymore. But I think if we just keep adding more images and eventually have millions of images, then this will be, we will get to something that's very close to almost perfect. So I'm going to finish with this little circle to just explain again what I just said. But I think it's very important, and it's a system that I think I would like to see also in other fields, but I cannot obviously do this in other fields. But so here's the fundamental principle, right? You start with a lot of non-annotated data, which is where almost every machine learning problem starts with. And then you somehow train, or you put this, then you have some algorithm, who knows why, maybe you did some project somewhere, but you have something, so you push it through a machine learning algorithm. And then you have some human verification or annotation. So that's when the human comes in and says, sorry, that's wrong, sorry, that's wrong, sorry, that's correct, that's wrong, that's wrong. But at the end of the day, you have perfectly annotated data. Just took you a long time if the machine learning algorithm is really crappy, but you have good annotated data, and that makes you happy, especially if you run a cohort with food. But this is the real bottleneck, right? This is why you can maybe only take a few people at a time, because that human annotation step takes a long time. But now, as I said, you have annotated data. So now you can create a public benchmark with this annotated data. And then if you do this in a smart way and put the right incentives into place, you can say, you know what? When a new algorithm is submitted in this public benchmark that beats whatever I have, I'm actually going to automatically deploy this as an API, which the app consumes. So in the ideal case, you wake up one morning and the app works much better, because overnight somebody submitted an algorithm that was automatically benchmarked. It was automatically decided that this was the best algorithm, and it was automatically deployed. And so, of course, now you go back to this, right? You now have a better algorithm, and a slightly better algorithm will mean your throughput will get larger. And if your throughput gets larger, you will get more annotated data for a better public benchmark with more potential to improve it and so on. You can see this is not only a virtuous cycle, but it's also one that sort of accelerates itself. We're at the very beginning of this. Again, it's round 2. But I would be quite shocked if, for example, next year at this conference, we couldn't, for example, say this has improved dramatically and our ability to improve the throughput has increased dramatically. So this was what I wanted to say. We were very focused on Switzerland, not because we're small thinking people, but because we said, okay, we need to first get this right, or at least get it started and get it right in a place that we know and where we use it ourselves. But then once we have the whole thing in place, which we now do, we should probably try to bring this also to other places, because I think the world would in general benefit from an open system like this, where everybody could just go and say, oh, I want to use this algorithm as well, and I want to implement it in my app. Then they can do with it whatever they want, build a product, build a business, that's fine with us. All of this is licensed under extremely permissible licenses that allow also the commercial use. That's totally fine for us. We just want there such a system to exist so that the academic world can benefit from it. Yep, that's my last slide. Thanks very much. Do you want to?
So I think we have time for a few questions. If anyone has questions.
Have you considered using existing recipes to get an idea of how the ingredients are combined together to actually improve the situation and everything?
Yeah, so recipes is a very interesting point, and we discuss about it regularly. At the moment, we don't have a concept of a recipe yet. It's just we have somewhere in the vicinity of 2,000 classes according to the Swiss food ontology, and we adapted a little bit. I mean, adapted, mostly extended. We didn't want to change it, but extend it. But then we have actually relatively little insight. So, as an example, you take any dish. Well, let's take a pizza. It's maybe not the best example, but you take a pizza and it recognizes it as a pizza because a pizza, the reason it can recognize it as a pizza is because a pizza is a class in that ontology. And now, because of data that we have also coming from the federal system at some point, there is some table that defines what is actually the makeup of a pizza, right, in terms of macro and micronutrient. But it would obviously be much better if what it could say is, it could say, I see the following recipe, right? I see the following end product of a given recipe. And then that would allow you to then much more fine-tune the system, because then people could say, that's exactly what I had, but I cooked it without this oil. So just swipe out the oil, right? And that's something we definitely want to do, but it's just, of all the things we had to do, we couldn't quite get there yet.
I think it was done by MIT. It's like, you can
Yep.
capture the dish and eat the recipe.
Yeah, exactly. So there's many I think good starting points around the world, and if certainly if somebody has already built something that we could just hook into, we will. That's what we'll do. Reality is sometimes a little different, but yeah, for sure. For as long as the license is as permissible as ours, and we have actually found, I have also personally found that this is a real challenge. I understand that people, especially in academia, sort of say, well, I put this out there in the open, but everybody should also put it out there in the open. And so they come up with all these bells and whistles and constraints attached to licenses that all of a sudden you can actually not use it if you want to be a very permissible project yourself. You're too permissible. And so we generally now very hard push for people to have more permissible licenses. Yes.
So I have two questions. I'm curious about the
It's supervised. It's just, it's purely, yeah, it's pretty, I think, I mean, I haven't actually looked at the latest, but it's pretty standard sort of image recognition, supervised convolutional networks, just based on the data that we have.
Okay, and if it's supervised, that means that you use the human crowdsourcing for the labels, right?
Yeah, well, the human annotator, yeah. So it's about the same 2-ish people who do this at the moment. But now that sort of hospitals are starting to use it, they have their own annotators that are now using, they're annotating themselves. But we can use it to improve the model.
And you also mentioned that in your database you have like food, individual food with specific barcodes.
Yep.
In
the food recognition. Yeah, in subtle ways. So the main idea of the barcode recognition is that if I'm just on the run and I take my bottle of water, you know, that I bought in Coop and my, I don't know, pack of nuts, then I actually don't need to just put everything on the table and take a picture. I can actually just scan the package. That's also in the app. So you can either take a picture or you scan it. You scan a barcode. And if you have that, but it's very much biased towards the picture taking. Say about 90% of the data that we get through the app is through picture taking. But 10% is through the barcodes. And it seems like little, but as a heavy power user myself, it would annoy me tremendously if that 10% functionality weren't there. Because sometimes you just have something and you would actually somehow have to really get it out of the package to make that picture. Or you take a picture of the package, but then it's not really generalizable because the next same product has a completely different package. So it's important for that.
Okay, just 2 more questions.
Since you started with mentioning health,
Yeah.
have you considered like outputting its health or not?
Yeah, we have considered that, but have so far decided against it for the simple reason that it's just philosophically a bit difficult, right? People have also asked us, for example, to put the Nutri-Score label in the barcode scanning app and so on. And so far we have refused, not because we couldn't do it or because we have certain opinions, but just because at the end of the day, I feel it's not up to us to make a statement about the health of a particular product. I mean, especially sort of going back to this whole reflection about personalized health, what is healthy for you may be not so healthy for me. And so to say this is actually healthy as a lab that's mostly sort of geeking out on the technology and building these tools, I would not be comfortable with that. I'd be very happy to say, for this product, here's another organization that has labeled this product as such and such. Here's the Eatery or whatever, all these organizations that are now also calculating the CO2 emissions from a product that has said this product does this and this to the environment. That I would be very happy to do for as long as we can say the following organizations have the following views about this product, but that it's not us who puts some sort of stamp on it and says this is healthy or not healthy. It's sort of a philosophy decision.
When is that, do you do any pre-processing of the picture? Like, because a statement can be an issue with machine learning algorithms.
Yeah.
And take a picture of the whole table or like your one individual employee upload using it.
Yeah. Well, so we do some pre-processing that again is fairly standard, but as with respect to the machine algorithm there, we completely leave it also to the participants in these challenges. We say, look, whatever you do, right? We don't care. I mean, we care for a geeky reason, but fundamentally, if we then apply it on our other test data set that we have of people that haven't given the public consent, right? That's a good test case for us. And it works. then it works. We don't need to know how you did it. So I cannot say concretely how the best machine learning algorithms that are out there at the moment have actually done it. One could probably get into it, and one could go over to the track to listen a bit to that, but we don't really know. But at the end of the day, I want to practically know less and less about how it's done, and I just want to measure that it really works. So calories we estimate, yeah. Yeah, exactly. But there we're mostly going with portion sizes and estimates at the moment, just because, I mean, one also has to say, right, we will have, I think, better precision than food frequency questionnaires, but the precision will nowhere near be perfect. But then, you know, people maybe easily leave 10 or 20% on the plate and are not letting us know. So I think there's going to be pretty substantial uncertainties around that. So we're not going to stress out over, you know, is this now a 20 gram or a 100 gram apple or a 110 gram apple? For us, what's important is that it's easy to do, that we say, okay, this is an apple, it's somewhere around 100 grams, and it was eaten at precisely this moment in time. And so that, right, when you use this app for 2 to 3 weeks, you actually get a fairly good and granular picture. But that's certainly going to be, nevertheless, quite have a lot of uncertainty around the edges of each single food item.
Thank you.
Good, thank you. Yep.